In this problem, we want to find the current I, and we want to do this using proportionality method. So proportionality method means we guess a value for the output quantity, and I'll guess that this current I equals 1 amp. As soon as you do that, you need to come back to your source and say that's the value that I'm trying to find. So I'll call that one Vs. So now that I know I have 1 amp flowing through the 6 ohm resistor, I've got a 6 volt drop here, and that means I likewise have 6 volts across the combination of the 4 ohm and the 8 ohm resistor. So 6 volts divided by series combination of 4 plus 8 ohms, which is 12 ohms, means that I have 1/2 amp through that portion of the circuit. Next, I can observe that this current and this current sums together to form this current right there, so that gives me 1.5 amps right there. And 1.5 amps through 8 ohms means 12 volts appears there, and we also have 1.5 amps going through 4 ohms, and that leads to a voltage of 6 volts. So the next big thing we can do is note that going from this node to this node is the same thing as doing a 6 volt rise plus 12 plus another 6 volt rise. That means we have a voltage drop, or voltage across the 24 ohm resistor of 24 volts. 24 volts divided by 24 ohms means we have 1 amp right there. Now I'll do a KCL at this top node where we have 1 amp plus 1 amp plus 1/2 an amp over there, 2.5 amps. So 2.5 amps going through 12 ohms gives me a drop of 30 volts. We also then have the same current in all of these devices. So that means we have a voltage right here of 30 volts as well. And I'll do the same thing we did earlier to get the voltage across the source. We have a voltage rise of 30, another of 24, and one more of 30, leading to a voltage and Vs equals 84 volts. So we assumed an output, this is my proportionality factor, we assumed an output of 1 amp and determined that that's produced by a voltage of 84 volts. I'm going to clear out the lettering right here, and this value is 11.9 millisiemens. Remember, Siemens is the same thing as amps per volt. So knowing my proportionality factor means that I can write the original requested quantity I as the proportionality factor times the input voltage, and we end up with 714 milliamps.